So total, we have 5 sessions, which will be organized in 2 days, that is today and tomorrow. So in day one session, total 4 sessions are going to be conducted, 2 sessions in offline and 2 sessions in online. And then the next day papers, here each and every paper has been reviewed by 3 reviewers from various states. And here, while reviewing the papers, the author and reviewer are not belonging to the same state. So while selecting papers, the first constraint we have considered is all the papers have undergone plagiarism using IEEE cross-check. So in that, when the plagiarism is below 30%, only those papers are considered, and the other papers which are having high plagiarism beyond 30% are rejected. And this conference has been started with a motto to promote technological and educational advancement of engineering fields. And this conference supports technological innovation and excellence for the benefit of the humanity. And this is an appropriate platform for collaboration and
Annual Chair Dr. Lakshmi Narayana, Professor of Andhra University and Vice Chair of Membership Development and Branding of its IEEE India Council, to share his insights into IEEE Vizag-based section and the vision for this conference.
Thank you very much. In fact, let me go back to the days when we really started this Vizag-based section in 2011. We are basically part of the Hyderabad section. In 2011, 3-4 people of Visakhapatnam really just said that we want to separate this section so that many of the IEEE events are happening in Hyderabad. We are not able to participate. Normally, Hyderabad IEEE conducts events, technical events, workshops, seminars. Every month, in fact, 1 or 2 will conduct it. When truly speaking, in COVID times in Vizag, we have conducted 196 events in 1 year, 196 events. And in 2011, we became a Vizag subsection. And later in 2018, we are applied for elevation to the food section. We are separated from the section. We are in 2020. And I'm the founding site for that 2020. And now Dr. Abram Varghese is sitting on the dais in the same way. I really give my wholehearted respects to Vice Chancellor, Professor Z. Seshwaralu, and Dr. Abram Varghese, who is on the dais, who is in fact Director of NSTL and outstanding scientist, and a weapon scientist specialist, and he has a project worth of more than some hundreds of crores with him, a team of nearly 600 scientists working under him. He is the main sponsor for this conference. I hope that we can give him a bigger platform. Truly speaking, I think most of the content what I want to say, Dr. Deepika Rani has mentioned. IEEE conducts conferences across the world, around 2,000 conferences a year, publishes more than 200 journals transactions in every year. There will be nearly 6 million publications are going in the IEEE Explore every year. All the Explore publications will go to scoopers. Therefore, people will be really interested in publishing the papers. There is a very strict norms for publishing in this kind of process. That was the reason that some of the conferences which are really short-sighted conferences will not appear in IEEE Explore. We conducted nearly 3 conferences in the place, and I think we conducted a couple of conferences with technically sponsored with Raghu Institute of Technology, Cecil Institute of Technology, Aditya University, and other universities also. Our team really is very disciplined and very strict norms to follow. Honestly speaking, I could tell that one of my paper also resulted in recent SSC conference. I didn't see that my paper was rejected, but it was rejected. Therefore, we see in that line, therefore, I basically look the quality of the conferences conducted. Conference organize a workshop every year, once or twice in every section area. In fact, IEEE has a nearly 4.6 lakh of members in the world. World's largest conference society, born nearly 140 years back in the US by a few scientists to solve a problem. Therefore, we basically at IEEE does humanities work, conferences work, support students a lot. In fact, India has nearly 80,000 members in India. Out of this, 50,000, 55,000 students are from students only. Out of that, Kerala stands the highest number of students, more than 10,000 students. The Professor Kasim basically is coming in the evening to deliver a talk to the students what the benefits get from IEEE. There is a huge number of benefits for students, in particular joining IEEE. I don't want to educate that IEEE in this forum, but I really request my students at other universities to really join this IEEE. And 2 days back, we conducted the IEEE Explore Worldwide. The program conducts 24 hours hackathon, new programs like that. And our neighboring college, the Lendi Institute of Technology, bagged rank number 1, 2, 3, 4, 5, 7, 8, and top 10 in India. And top 23 ranks in top 100 in the world. And this is the thing what were done by the students at Lendi Institute of Technology, where I am the student activity said at the present at this section. I'm really proud to say that part. And I think that by evening we are really starting the membership development conference at this place. Students can join that. Or professional members also can join. And we'll be conducting one more conference just now. Our said Punjab section has given his consent that we conduct another conference in collaboration with many institutes, etc., so that we give opportunity for the younger researchers to really publish the papers. In mostly we consider students' papers also. Our fees for students is much reduced in case the registration fee for a paper in a for purpose of a number it is 8,000 per student we take only 4,000. In fact, conferences will run fiscal and last month, not in profit more than this is one of the concepts we look into. We do not work for any financial profit from conferences. We want to really disseminate the knowledge. We see, I could see people from BHU, Varnas, and Hyderabad, and some people from other institutes, other states are coming. In this paper, in this conference, we have papers, 4 papers from US, 1 paper from Germany also being accepted in this conference. Therefore, people know the quality of IT. Therefore, we need to really look in that direction, joining hands with IEEE in every corner. In fact, we have a program on Fifth Tech to Novatech. If there is any professional members that are representing the institution, they are invited 1%. Learning methods of this thing, I request to the people who are here, Raghu Institute, other institutes also, they can nominate the people, they can come. And I'm also taking one session in that this thing. Learning process to IEEE for engineering education is I will talking about a lot. Therefore, this kind of a thing, add-on kind of a things will really helpful for students. I hope that my students, my college students, I work here for 24/7 as a professor in the Department of Computer Science. Therefore, I believe that my students also will get benefit of IEEE. And I feel that I'm proud to be here to stand before you and say some few words about that. Really, I thank my team who really assist me and put around me and our child and other people and Srilakshmi from Hyderabad, other people who really helped me in processing each of the five process of the papers, what they really thought about it. We thank our reviewers. We have used nearly 422 reviewers for really reading the papers and understanding it and giving their consent. 422 reviewers. Out of them, not less than 50 to 60 from abroad we are choosing. Therefore, our papers are gone through a very rigorous process before acceptance. I really thank the organizers who gave this opportunity to stand before you. Especially, I thank our Vice Chancellor who really made his time to come and bless us in this conference. Thank you very much. Thank you.
Thank you, sir, for sharing these valuable perspectives on our section and this prestigious conference.
Now I invite our General Chair, Dr. Abraham Verghese, sir, an outstanding scientist and director, NSTL, DRDO, and chair of IEEE Vizag B section, to introduce us to the conference program.
Today's chief guest, respected Vice Chancellor of Andhra University, Professor Teacher Rao, Dr. S. Narayana, Chair, Professor Divya Rai, TPC Chair, and faculty members from the university and various colleges, and my dear students. I'm quite delighted to be a part of this international conference of intelligent systems and smart agri technologies. Dr. Lakshmanaran was clearly spelled out how this IEEE Vizag section has evolved into a independent section. We were part of Hyderabad section of the subsection, and subsequently we have come to now as an independent section. And the what of the program, everything, Dr. Deepanani also clearly. I would like to tell you, who is sitting here. As you all know, our country is everything where scientific development is happening now. So we want to catch up with the developed nation. If you see the developed countries, the most of the research happens in universities and academic institutes. As a part of the DRDO, I know. Now the technologies which are required for our armor forces we are developing in DRDO. But we want to involve the academics and the other institutions to a great extent. Now the government's endeavor is to spend the 25% of our R&D budget in academia. So this happens in the developed nations, especially in the US. You know, most of the critical technologies come from the academia. So academia has to play a great role in the development of this country. That is possible only if you nurture innovation in academic institutes. Innovation can be of many types. Innovation can be a technology innovation, where you come up with a new technology. Innovation can be a process innovation, where you come up with a new process or a better process to make a product. Innovation can be a marketing innovation, where you develop a better marketing technology or marketing strategy, as Geo has come up with a good marketing strategy. Innovation can be a business innovation, where you come up with a very good idea of a new business. So innovation can be of any type. So you need to nurture this innovation in young minds. That is the beauty of our academia, our academic institutes. If you nurture these talents and if you channel these talents to such innovation, then our country will be able to develop all the technologies indigenously. Our Prime Minister's vision of Atmanirbhar Bharat, you have heard about that one. That means country has to, all the technology has to be developed inside the countries. So now we depend on the foreign nations for some of the technology, some of the technologies we import. All those situations can be avoided if this type of forums we make use in the correct way. These are the forums where we can exchange of ideas. We will be meeting the academia members, scientists, engineers, where we will get a place to showcase our ideas, take it further. So if such forums, if we make use of to full extent, then we will be able to develop technologies in the country where we will be independent of the import technologies. Our Prime Minister has got a vision of Vikasit Bharat by 2047, sorry, 2047, we have to have a Vikasit Bharat. So I urge all the youngsters who is sitting here to take that forward and develop technologies in-house and use this type of fora to inculcate the habit of innovation. Thank you for giving me the opportunity to address all of you. All the best.
Thank you, sir, for such an illustrating comprehensive program. It is my honor to introduce today's chief guest, Dr. G. Sashibhushan Rao, sir, Vice Chancellor, Andhra University. Dr. Rao has over 22 years of experience across R&D, industry, and academy. With over 500 publications in prestigious journals, including the IEEE AES journal, he has been recognized with the Best Researcher Award and Dr. Sarvepalli Radhakrishnan Award for the Best Academician. His research contributions span GNSS, ADAR, and sonar signal processing, and he has notably contributed to the ICAO standards for ionosphere ethics on GNSS signals. Dr. Sashibhushan Rao is also a senior member of IEEE and a fellow of IEEE with memberships in several esteemed international societies. Dr. Sashibhushan Rao, sir, we are truly honored to have you with us. I invite you to enlighten us with your views of wisdom.
Thank you.
As Dr. Abraham Verghese, outstanding scientist, General Chair of IEEE, Director NSTL, Dr. S. Lakshmanaran, Professor and General Chair of IEEE, Professor Deepika Rani, TPC Chair of IEEE, faculty colleagues, heads of the departments, Professor P.N. Rao, Professor Venkat Rao, Andhra University Vigilance Officer, Professor Chitbagar, Dr. Ramji, CH Department, students, participants, ladies and gentlemen. Good morning and welcome to the IEEE Conference on Intelligent Systems, Smart and Green Technologies, abbreviated as ICISS GT 2024. With great humility and pride, I stand before you as the in charge Vice Chancellor of job. Other companies. Eighty-five percent of the applications in all these sectors are expected to be AI and ML based, or they will be integrated with the AI ML tools. If you see the growth rate, the importance and the importance and promising future of AI and ML, which is making them indispensable areas of study and specialization, particularly for those who wish to stay at the forefront of the state of the technology and innovation. I was told that this conference was postponed from 2023 November to this year, and finally it is happening now. As already our Professor Lakshmana has mentioned, IEEE is the world's largest professional body, maybe society, with more than 4.6 lakh members across 160 countries, wherein I am also a member. Probably I am the senior most IEEE member as well as senior member of the IEEE. I don't know if you were there, I should say I became an IEEE member in the year 2003 or 4. A senior member in the year, I think, around 2006. Must be. As a senior member. I am deeply grateful to Professor S. Lakshmana and Dr. Abraham Varghese for their dedication and support despite facing several hurdles and criticisms with respect to the scientific conference. Finally, I would like to express my gratitude to all our honored guests for joining today. Thank you all for your attention. Thank you. I wish you all success in all your future endeavors. Thank you.
Thank you, sir, for your inspirational words and insights on this conference. We really appreciate your presence here. So, our next segment will be the release of the souvenir. We now request our chief guest, Dr. Sashi Bhushan Rao, sir, to kindly release the souvenir. I also request all the dignitaries on the dais to join this memorable moment.
I request the ACC members of White Bay section and Professor Venkataraw garu, Professor Chittwa garu, Professor Ramji garu, Professor Mallikarjuna garu, Professor Sri Lakshmi, Professor Rajeshwara garu, to join us in releasing the seminar. The strong
Now we request our general chairs to felicitate our chief guest. I also invite all dignitaries onto the dais to join this special gesture.
Now, let's do a word of thanks. Uh, it is my honor to extend a formal word of thanks on this special occasion. First and foremost, we express our deepest gratitude to our chief guest, Dr. G. Sachibhushan sir, for his gracious presence and inspiring words. Your contributions to the fields of GNSS radar and signal processing are invaluable, and we're grateful for the support you have shown us today. To our general chairs, Dr. Lakshmi Narayana sir and Dr. Abraham Verghese sir, thank you for your invaluable leadership, vision, and commitment to making ICI SSGT 2024 a grand success. We extend our heartfelt thanks to Professor Deepika Rani ma'am, our TPC chair, for her dedication and guidance in bringing together such a diverse and impactful set of presentations for the conference.
Our sincere appreciation goes out to Sri K.V. Sriram sir, our organizing chair, for his unwavering support and tireless efforts to ensure the smooth execution of this conference. We would also like to thank each of our conference committee members, participants, and distinguished delegates who have joined us from various parts of the country and abroad. Our engagement and contributions made this conference a thriving forum of knowledge. To the volunteers and organizing committee, your dedication and hard work behind the scenes have made this event seamless and enjoyable. Thank you for your immense efforts and commitment. Last but not the least, we extend our gratitude to the press and media for covering this event and sharing our vision and achievements with the larger community. We have specially invited Dr. Abraham Verghese sir after the break. So let's have a short break for now.
All the participants, can I have your attention for 5 minutes? I would just like to inform you that snacks are being provided outside, so please go and have your refreshments and join us after the break. Thank you.
Online one second or maybe how much money you got for your education?
Sir, thank you, sir. Online section of close it in. Sir, actually, panic and message పెట్టేటప్పుడు క్రీనాగర్ simultaneously జరుగుతుంది. Actually, sir, మీకు ఆఫ్లైన్ చేస్తా ఉన్నారు. మళ్ళా మీకు అక్కడ మళ్ళా మీకు ఒక మూమెంట్ లో చెప్పాలని ఆన్లైన్ షవరింగ్ గారు రిజిస్టర్ చేసుకుంటాము ఫస్ట్ సార్ చెప్పండి ఖచ్చితంగా మీరు వెంటనే యాక్సెప్ట్ చేసుకుంటూ సబ్మిట్ చేసుకోవాలి థ్యాంక్ యూ వెరీ మచ్ సార్ నేను వచ్చిన తర్వాత మళ్ళీ పరిస్థితి
Ready to set up. మీరు ఇప్పుడు చూసుకుంటున్నారు కదా, ఒక సాంగ్ లిస్ట్ కూడా పెట్టాను మరి వర్షం మీ దగ్గర వీళ్ళ కాంటాక్ట్ నెంబర్స్ కూడా ఉన్నాయి కదా ఒకసారి నంబర్ తీసుకుంటాను కాల్ చేయవలసి వచ్చింది రెడీ మెసేజ్ 654. Right. The rate of the monkey will magic is
అర్థం చేసుకొని తెచ్చాను కోసం
నాకు తెలిసింద్ర బాబు అక్కడ ఫ్యూచర్ మ్యాప్ లో నాకు నిల్చొని అడిగిన ఎంతమంది వస్తే ప్లేస్ మీద కూర్చోడానికి మైక్
ఆఫ్షన్ అండి ఆన్లైన్ ఆఫ్షన్ ఆఫ్షన్ ఎందుకు కొంచెం మనం ఇద్దాలి ఎక్కడ కూర్చొని కూడా కళ్ళు కూర్చొని కూడా పడవా వాట్ ఉందా
So, welcome back everyone. Now that you all have had your
In fact, we have a special session by Sir Mohammed Asi S. Who is saying for Kerala section. I need to mention a couple of words about Kerala section. It is the world's largest section with 14,000 members in one section. How could you manage that kind of a section where nearly 10,000 students join? Kerala has a number of institutions lesser than Andhra Pradesh, but the people have joined many. The reasons are many. The benefits are many. Therefore, I requested Professor Kasi, even title is different, but I requested Professor Kasi to come over and to deliberate the methods and how basically what are the advantages and opportunities for students who basically gain from IEEE, who really experiences from IEEE. I want to express, that is, I request him to express his views on that. He is present in the flight, he will be reaching around 1 o'clock or so, and he will be delivering to 3 o'clock can join that session. Thank you.
Okay, so now that you all have had your refreshments, let's continue on with the session. So next up, we have a special invited talk by Dr. Abraham Verghese, sir, an outstanding scientist and director in NSTL, DRDO, and chair of IEEE Vizag-based section. Dr. Abraham Verghese, a scientist, assumed charge as Director, Naval Science and Technological Laboratory, NSTL Visakhapatnam, on 1st of July 2023 An alumnus of University of Kerala and IIT Delhi, Dr. Burgess holds a doctorate in computer science and engineering from Andhra University and was awarded the gold medal for best PhD in engineering stream. He has a vast experience over 3 decades in the design and development of underwater weapons and laboratory. He is the chairman of IEEE Vishakhapatnam Bay Section and a fellow of several professional societies.
Good morning once again. I will continue from what I started during the as I was mentioning, it is the duty of academia to foster the research in the country. If you go through various developments in the defense or in the other area, most of those inventions or discoveries primarily came from the academy. So earlier, our country that was not feasible or that was not happening that way because of the various factors. But now the infrastructure in the country has improved. We have got systems or we have got the circumstances or the in place so that the research can be initiated in a better way. So it is also the endeavor of our government to have the 25% of our defense R&D to be done or from academy. So as I was telling earlier, it is possible only if the youngsters inculcate the habit of innovation in the creativity. It was also mentioning about the different types of innovations which you can inculcate in you or cultivate in you. So there is a necessity to culture the scientific temperament in you. If you see the term scientific temperament was coined by our first Prime Minister, Pandit Jawaharlal Nehru in his book Discovery of India. So the term scientific temperament first came in the book. I don't know how many have read the Discovery of India. So if you see the data, some data in the internet which I was seeing, the number of patents filed in each country since 2021. China stands the first, followed by USA, Japan. But somehow we are not able to figure in that place at a very high position. China has filed almost 15 lakhs patents, and US has filed 5 lakhs. Now figure is around 70,000, but now it is increasing. So this can happen only if the fundamental research happen in the country. The fundamental research can contribute to inventions and discoveries. So as our first Prime Minister has told, the culture of scientific temperament is an environment of active attitude, where everyone was in a synergistic manner for a moment. See, the world now is quite unpredictable. The technology is every day you see that today's technology is not there tomorrow. So every day the systems are changing, the technology is changing. If you for an example, the pandemic has actually exposed the fragility or fragility of our systems. But it has also given an opportunity for us to demonstrate our what you call the collective strengths. Pandemic has literally given us an opportunity for that. So we could build systems in quick time to counter that one. The vaccine has come very fast. Recently, I could hear the talk by Dr. Priya, who was the heading at that day. What you call Institute of Virology at that day. So the efforts they have done in making a vaccine and countering the pandemic. It is almost a 24-hour everything. So she was narrating the teamwork which has led to the government to a vaccine. So many unknowns we need to encounter and tackle. This is possible because of a culture of scientific development. So if you want to inculcate such a habit, it cannot happen at a job place. It has to happen along with you in your education system also. Many faculty members are here. So it is your duty also to inculcate such a habit in the youngsters. When they learn your first years of engineering. So it is not just the campus interview only, should not be in your mind. But if you inculcate such a habit or grow such an attitude slowly, then you will be able to come to such a R&D kind of mind. So students should be given an opportunity to be curious. So they should ask questions and they should be able to test their hypothesis or experiment and innovate. There are several issues with us in front of us, like climate change, conflicts, biowarfare, uncontrolled artificial intelligence, and other unforeseen technological changes, which will certainly throw up great challenges in front of you. So, the universities and academic institutes must train the future citizens to be future ready. So, you need to encourage, educate, and affect. Then only you will be able to get a better citizens tomorrow. So there are several focus areas in that one. So invest for the future. You cannot venture into this one with empty pockets. So empty pockets will not take it. So we need to have proper funding for that one. Equipment. The bad tools will always be bad products. So we need to have good tools or softwares which will enable this one. And you need to develop people to lead, develop leaders, motivate. Universal part to be role models. The beginner's mindset from. So you need to sustain that beginner's mindset and allow the people to see beyond. If you see the various technologies which are happening now, as it was mentioned earlier, the AI and ML is one area which is coming up. So other than that one, if you see fundamentally, the materials is one area where we need to come up very fast. If you see several advanced country systems, their material technology is in a very high state or advanced state. You see some of the important material of an equipment. You will not be even able to understand what are the material. Material science and more heat resistant, improving the performance and safety of vehicles, systems. And the carbon fiber composites are one great area which is coming up, which will reduce the weight. If you see the aerospace industry, it will increase the fuel efficiency and enhance durability. So material science is one very area which will come up. Even your design of antennas, about the metal materials. So which will make your antenna design very simple and very compact antennas you will be able to develop. So another area which is getting the electric propulsion. So now we are thinking of electric propelled aircrafts. So we had only the earlier electric vehicles. So now all electric ship, generally ship gets power from a turbine or from a diesel engine. But the concept of all electric ship is not coming up. Entire ship is powered by electric technology. That is possible because of the battery advancements in battery technology. You know, the lithium-ion battery technology is now is everywhere. So now you are getting systems where the energy to your ratio of energy to heat is very big. So such system will enable now the future. You will have the all electric shapes, and further, it is not only battery technologies. You are prime also asking electric motors. You all are working on BLDC motors and we have some motors available. So where you have got the your back energy, back EMF will be a sinusoidal. All your vehicles are charging. Your electric controllers, the chips, which can control the electric propulsion better. All those solid state. Remember, your earlier your computer used to be occupied 1 big room. So now you have got in your palm, you have got a computer. So this is because the material science has evolved in a great way. You are able to get better materials in that. Area which is getting involved. And signal processing in electronics is another area which is rapidly expanding. There are new algorithms which are coming to the signal processing, which will be able to take or take decision for a detection in a very small time. So you have got highly efficient algorithms. So earlier used to have Fourier transforms, then you used to have fast Fourier transforms, which could make a very easy detection of a signal, emits noise is very easy because of all those things. Now you have got so many other transforms are come, equal transforms. So all these are making your signal processing very easy, and which will enable in your image processing, in emerging technologies, it will make expand that domain very fast. Another area which is coming up is the sensor technologies. Earlier, used to have sensors, very big sensors, which can detect physical parameters. We always, in order to interact with the physical parameters, you need to have a sensor which will convert your actual physical parameter to electric parameter. So these sensor technologies are also now getting evolved. You are having sensors which can detect anything. So that's how the sensor technologies are coming. So that also has got a your material science also is leading to having better sensors. So that we'll be able to make more compact sensors. So another concept which is coming up is the networking. Earlier you had network computers, but then you came to the internet which came up from the defense area, defense agency in America, DARPA. Then you came to IoT, your Internet of Things. All your sensors are getting connected, and you are able to exchange information in a very way. Your TCP/IP stack is becoming very small, and it is being embedded into sensors. So that any sensor with the TCP/IP stack is able to communicate more area, more area in a very easy way. Other areas which are coming up. The sensor technology, all our instrumentation systems, because of the advancements in sensor, are becoming very easy now. So now you know the pump dogs, which can pressure you are seeking or the pressure. Possible only because of the advancements in sensors. We are able to make compact sensors which are able to detect parameters in a better way always. So this is the another area which is coming up. Of course, the computers, your memory area. You need to have, see earlier your memory, the first embedded system which was on the Apollo guidance computer. The Apollo mission, the Apollo mission. So it was on the Apollo guidance computer, which is actually officially that is the first embedded computer in the history of the mankind. So that had only 4K microcontrollers, and the guidance program was only some 10-15 lakhs. From there down you have come to the memory. You see the memory which you are using now. So that is the type of memory now you are using. So that is also possible because of the advancements in the integrations. When you the last scale, you are able to get better memory and better processing also. The microprocessor which was used in the Apollo guidance computer was very less. So all these technologies are young skills. You people need to, when you're into all these technologies, you need to keep abreast of the technology, otherwise you will be left behind. So my advice to the youngsters is don't stop learning. If you are out and if you are doing a job, but don't stop learning. You should be a learner always. So then only you will be able to keep abreast of the technology. There are opportunities. Government is giving so much opportunities now. The startups, MSMEs, everything. Government funding is also available. Somebody who is good in entrepreneurships, everything can take up these challenges. Right? We have got defense challenges, technology development funds are there. Government has got so many schemes now. So for youngsters who would like to venture into, you don't get settled by just by a job or a IT job. So there are 4 areas where you can explore, where you can do better things and contribute to the country, whereby you will be able to make this country advanced country and reach our Prime Minister's vision of leadership by 2047. Thank you and all the very best.
So thank you, sir, for your valuable insights, and that was a very inspirational speech. We all had a wonderful time listening to your words, and we really appreciate your presence here, like I said. And yeah, let's move on to the next section. So we'll have a short networking break for now. So all the students here and all the audience can go and network with each other, build connections. After all, that's what we're here for. IEEE is all about building networks, having connections, improving yourself, and having more knowledge. So yeah, let's have a short networking break.
All committee members తెలండి డాష్ వరకు కమిటీ మెంబర్ మన కమిటీ మెంబర్ ఓకే మేడం
All volunteers and all IEEE Wiser Bay section committee members, organizing committee members, just join on the dais. All the committee members, please join on the dais. Lakshmi madam.
శివకుమార్ శివకుమార్ ఓ శివకుమార్ గారు హాయ్ బాబు ఎవరు ఉన్నారు శివకుమార్ లేరే Shiva, it's me, still. Press call on copy, just a short.
సార్ ఇదిగోండి ఇక్కడ రెండు పెట్టి ఉంచాను ఇది కూడా
फोटो के लिए बुला रहे जो फिर नहीं है
ఇంకా ఉన్నారు
अब्राहम सर
ఇంకా ఉన్నారా
सर अక్కడ ఏయో టీచర్
వాలంటీర్లు పిలుద్దాం అప్పుడు ఇది రావాలి కదా
बैनर है
Volunteers come, volunteers. Next. Come 5 days. Let us come close.
बैनर पड़ता
Okay. Wait. Atas.
होगा मेरे तरफ
Session starts. వెళ్ళిపోతున్నారు selection. Thank God, now we got to on 10:30. ఆ తర్వాత అప్లికేషన్ తీసుకొని నేను వచ్చి చేశాను. మా దగ్గర ఫ్యాకల్టీ అయితే వాళ్ళు పార్ట్ టైం ఇస్తాం. ఎవరి దగ్గర పంపిస్తాను 10,000 పెట్టుకొని నిద్రలు ఇస్తాను.
హైదరాబాద్ వైజాగ్ కి కలిపి 250 ప్రైస్ మమ్మల్ని అడుగుదాం వెయిట్ చేస్తాం. మేడం ఉన్నారు కదా
అది అలాగైతే కొన్ని లక్షల వాళ్ళు మాకు కలిపి 60 లక్షల్లో 30 లక్షలు మాది.
ఆ డబ్బులకి చాలు కదా
నాకు పంపించండి. అమితికి పంపిస్తారు. అమిత హైదరాబాద్ పంపిస్తే సెక్షన్ నుంచి ఒకరు మాట్లాడినాడు 2 అవర్స్ ఇస్తారు. ఇస్తారు ఎంత అంత ఇవ్వలేము. డబ్బులు ఇలా 60 లక్షలు లేవు మాకు. మా దగ్గర డబ్బులు లేవు. ఒక 10,000 15,000 పెట్టుకుంటే ఇస్తాం. అమితికి పెడితే కాదు, విజయలకి పెడతారు. ఇంకెందుకు పెడతారు? అవచ్చమ్మా, ఇప్పుడు చేతికి పెడతాం. డబ్బులు ఎవరి దగ్గర ఉన్నాయి? ఈ ఎండలు వచ్చి మీరు అంత పెట్టేదాకా నెయ్యి ఫార్వర్డ్ చేయండి. డబ్బులు ఇస్తేలేమి కాదు, రాలేదండి.
మేమే అలాగనుకుంటున్నామంటే కానీ ఈ కాంపిటీషన్
రాలేదని చెప్తున్నాను. అంటే వీళ్ళకి వెళ్తాడు చెప్తారు. మీరు అందరు కలిసి నాకు ఇండియా కావాలి చేయండి. నేను అక్కడ అడుగుతాను. హైదరాబాద్ అందరూ చేయాలి. మీరు ఒక్కరు చేస్తే కుదరదు కదా. అందరూ కలిసి ఓట్ చేయాలి. నాకు చెప్తే ఆడవాళ్ళందరూ ఆడవాళ్ళు ఓటేస్తారని చెప్తుంది ఆవిడ. అలా అంటే ఆడవాళ్ళందరూ ఆడవాళ్ళు ఓటేస్తారు, మగాళ్ళు కూడా ఆడవేస్తారు. కొంతమంది ఆడవాళ్ళు కూడా మగాళ్ళు కూడా ఆడవాళ్ళు ఓటేస్తారు. ఎవరు
ఆర్డర్స్ అందరూ కనిపించి ఒకసారి చెప్పేసి
Paper number 469. नहीं लग रहा है व्हाट्सएप पे
Okay, thank you. What I want.
So now let's continue with the rest of the paper presentations from session 1.
No. Thank you.
What is the content?
desktop में करके ना अगला open है
Open this. Make this one.
yeah
Sir.
Good afternoon. I'm Dr. Sri Shobha. Today I'm presenting my paper, Performance Analysis of 31 level multi-level inverter-based PV system with the modified incremental conductance method and observed methods. The contents of the presentation are the importance of the standalone system and then block diagram of the actual system, then PV panel specifications, what we have simulated, and 31 level multi-level inverter importance and its advantages, then operation based on what switching states we are getting the operation. Then the two methods, incremental conductance method and modified incremental conductance method, and the simulation results. This is the sequence of my presentation. Now, so the advantage of standalone system is, first thing, it won't depend upon the actually means autonomous. Fully it is so self-sufficient. Second one is wherever there is no feasibility to edit the connections from generation to the load centers. So remote areas. So they we can this standalone system will act like emergency backup also. And another green energy is obviously PV system. And as we are able to obtain the continuous power supply, it is more reliable. And another feature set low maintenance, silent operation. Next one, this is the block diagram. So PV panel to DC converter in the block. At this level, we connected we know which is interfacing the software and the PV panel. Next. So these are the ratings of the panel what we have used. And 25 watts is the maximum power point. And short circuit current is 28 amperes. VOC is 22 volts. And the shunt and series resistances are 405 and 1.05 ohms respectively. So this is four levels. So what are the block diagram is shown? It is for one level. The simulation part we have extended to 4 levels, and this right side part is 31 level multi-level inverter. And the operation sequence of these switches S1, S2, S3, S4, and also S5 to S8 is given in the next table. Okay, this is the reason why we are using the multi-level inverter. Reason is to reduce the actually number of switches what we are using will reduce with this topology. Other topologies if are using for the higher levels, the number of switches will increase. So that is the reason. And the low ratio of voltage level to DC source isolation also feasible, and maximum output power in spite of fluctuating irradiance, temperature, and load conditions, we can obtain the maximum output power. And we can adjust the voltage ranges because 4 stages are there. By connecting, we can modify the voltage levels, and multiple number of DC to DC converters we can avoid. This is the advantage of the configuration. Next. So this is the switching states of the switches, so that so 0 voltage to each level 1 volt to 15 volts DC. The switching modes are S1, S2, S3, S4, when all the 4 switches are there. So 15 volts DC we are going to obtain. So like that 14 volts, 30 volts, the sequence. Next. And this is the polarity, positive 15 volts, 0 plus negative side. So total 31 states we are going to obtain. So this is the sequence of switches and the voltage levels V, B, S1, S2, S3, S4 will giving us VDC, 2VDC, 4VDC, and 8VDC. And 5, 6, 7, 8 switches related voltages are equal to 15 volts. Now, with this, the waveform, output waveform of the converter when we operate. This is the 31 level, red color one is the 31 level output voltage we are going to obtain related current based on the load, R load, and RL load also we can check. Next. So, the oldest spikes what we are getting at the starting positive and negative half cycles is because of the inductive loads whenever we take up the inductive load. So in order to overcome that, capacitor compensation is also incorporated in the 31 level converter configuration. So that is the reason inductive load of the output current lags. Okay, because of that, to reduce those spikes, we are connecting the capacitor compensation. This is the explanation part of that. Due to the voltage spikes appear in the output voltage beginning in the positive and negative half cycles, the value of alpha is higher for low power factor ranges. So in order to solve this problem, capacitor compensation is involved. So these are the modes of operation. The switching sequences are given in the previous table. So if we consider those switches, S5, S6 are on, S7, S8 are off. In this mode, what is the circuit and how the currents flow? The resultant voltage across the capacitor, what we are going to obtain a related current. So these are the four modes. So S5, S6 are on. This is one mode. Next, this is S7, S8 is off. So in the reverse direction, we are going to obtain this is second mode. And similarly for the other S7 and S8 switches also, two modes we will be having, mode 3 and mode 4. So this is about the mode 3 and mode 4. So after operating the switches in that particular pattern, we are going to obtain the 31 level output. Now, so here, fortified absorb method, implemented conductance method, and modified incremental conductance method. Three methods we have done. So, fortified absorb, I'm summarizing here. Show the results of incremental conductance. The modified incremental conductance method. So here in this MPPT oscillation oscillates at maximum point per point, whereas steady MPPT we can obtain in the incremental conductance, and second time is better in case of incremental conductance method. So with these advantages, so this is the flow chart for the incremental conductance method. In this, by incremental value of voltage delta V and delta I we are considering in order to reach to the maximum power point, to track the maximum power point. That is the logic in this particular incremental conductance method. What are the divisions? In this particular concept, we have formulas also. So this is the delta P with respect to delta V. If you see 0 plus negativity, and left side means negative slope and positive slope we consider in order to approach to the maximum power. So 4 is the equation. So next. So in this incremental conductance, this part is the modified one. What exactly we are doing in case of incremental conductance is next.
this B and delta I. Output power and for the different value of irradiance and then so by connecting the load here see, resistive resist portable and okay directly THD. This is with the CC the THD value, the improved value of THD we can examine next. So these are the values, actually three methods with compensation, without compensation, R load, RA load, many are there. So what are the results based on which we can compute the conclusions? I have selected those output waveforms and the results. So here, table. So voltage and current THD or voltage and current settling time with portable and observed method. So upper part is without capacitor compensation. So same parameters with capacitor compensation in incremental conductance and portable and observed method. So here from the results we can observe clearly that THD improvement. So capacitor compensation THD is 3.412. It is 3.21 and for current it is 1.29 to 1.21. There is an improvement means better quality of output we are getting with this incremental conductance method. Settling time also reduced 0.08 and voltage and currents are 357.2 volts and 0.495 amperes. This is the comparative analysis of the results what we are going to obtain for all the methods. And then, so conclusions, coming to the conclusions. 31 level switch diode based multi-level DC link inverter operation implemented including capacitor compensation to reduce the voltage spikes and MPPT portable and absorb technique is swapped out for the revised incremental conductance method and the revised incremental conductance method reduces the voltage, total harmonic distortions and the improvement in the settling time and the reduction in the THD is matching IEEE standards. Next. And according to the experimental findings, enhanced method can effectively follow the maximum power point without any fluctuations, means oscillations. Even though there is a variation in the load and the simplification of the system structure, low cost and low maintenance. The suggested technology could be a cost-effective alternative for PV power generation system.
Shri Shobha.
Yeah.
Thank you for the presentation. You see, this is only simulation, right? Whatever you have done. So, and what additional hardware, see, your operating system better output as compared to the previous ones. What is the overhead or your hardware if you're going to realize it in a practical level? Did you estimate that?
Yes, sir, yes, sir.
See, you have proposed four type of improvements
Hmm.
from which you have come slowly. And additional features you might have added. There is some additional hardware, right?
Hmm.
Apart from the logic what you have presented.
Yes,
You
sir.
want to realize it,
Hmm.
you need additional hardware.
Hmm.
Does it add much to your existing one?
Yes, sir, Arduino. So in the project software, whatever the enhanced code we are trying to implement, Arduino is the interfacing unit, with which we will get the better results.
So you
Industrial level Arduino is not support. The prototype, you can use it
Yeah.
as an Arduino.
Yes, sir.
That is what additional components and what we are fixes for it to be in a real time.
Here, actually, in the converter level, we have reduced the lot of configuration. Like, other than this, if you are trying to obtain the output, there are many converters. DC to DC converters number will be more. So here we are reducing. it. So when number is reduced,
Yeah, we will do for your presentation. That is asking to make your simulation into real time.
Huh.
What are additional things that have to be done? Maybe you have to change your embedded code. That will not be good for industry
Yes,
standards.
yes.
Then you have to change some features, bring it to in the real time. So that's part that is asking. How we can make this into a real time?
okay, rating of the switches, what we are using in the inverter level. DC to DC converter and the 31 level multi-level inverter, their switches ratings we have to increase and the board also. Both are practical things. I have to check the actual configuration, whatever is available in the market, and that I have to check it. Sir.
Because the simulation cannot resemble the real time.
Yes, yes.
can you do it practically also?
Yes, sir. 100%. We can implement this practically. Only within this prototype, we have to scale it up. All the ratings and whatever tablets we have to take and standard boards we have to select and switches if we upgrade, definitely we can do. Yes, that part we can do.
I wish you demonstrated
Thank you. Thank you.
Any other questions?
Thank you, members, for wonderful presentation.
Hmm.
Ma'am, I'm having one doubt. If you are able to analyze the huge size in a
Thank you very much.
Thank you, sir. Thank you.
Thank you. The next paper, paper ID 473.
ఇది డౌన్లోడ్ చేశారా
Let me.
ఇది రిమూవ్ చేసి This 485.
This
485. 480. First.
Good afternoon, everyone. I am Shravani, Senior Assistant Professor from CBR College of Engineering, Hyderabad. Today I am here to give a presentation on accomplishing power flow with UPQC in distributed generation system. Here, if you go with the renewable energy sources integration or DG integration, we have to face the problems of power quality. To overcome these problems, here UPQC, Unified Power Quality Conditioner, is used. So, to compensate the power quality issues, integrating of UPQC in distributed generation system. So, coming to the overview of my presentation, objective, introduction, description, results, conclusion, and references. So because of increasing load demand, we are penetrating towards the distributed generation services like solar, wind, fuel cell, and battery integrated system. So we have to face the problems of power quality issues like voltage sags, swell fluctuation, and harmonic problems. So to overcome this one, renewable energy based distributed energy integration, we have to go with the fax devices or any compensating devices. The main objective is to integrate the ubiquitously based distributed generation system. Here we have to concentrate on renewable system maximum power extraction, at the same time coordinating the load and the grid with the help of this compensating device. So here fuel cell, solar, wind based DG system is used, which is connected through UPQC while integrating into the grid. So to improve the power quality and grid stability, UPQC is to at the same time power flow to manage the power flow. So among all the power quality problems, here we consider voltage related problem, at the same time harmonics. Main theme is to here because of the changes in source or grid side, voltage fluctuations should not affect the load. At the same time, nonlinear loads which were connected at the load side should not affect the other loads or the source. So we are concentrating on load side harmonics and source side voltage balancing. Means load should not affect the grid. At the same time, grid side voltage variation should not affect the load. So to overcome these two-way, we are using the UPQC, which is a series shunt compensating device, unified power quality conditioner. Generally, for current related problems, we go with shunt compensation. For series compensation is used for voltage related problems. So to concentrate on both voltage and current related problems, we have chosen a series shunt compensating device, which will mitigate almost all the power quality problems, which will be incorporated due to the DG integration. So this is the introduction of my presentation. Generally, because of increasing renewable energy sources integration, we are penetrating towards DG association. And because of this integration, we have to face the challenges with integration. Main is balancing the source and load at the same time to concentrate on the same power quality issues. Next. So, what is the purpose of using these compensating devices? Just voltage compensations or voltage regulation, harmonic mitigation, power quality correction, and flicker reduction. Here we concentrated on harmonics and voltage related problems. So this is a literature review. So already just now I explained for voltage related problems, series compensation. These are the available research. For current related problems, STATCOM, which is a shunt related problem, shunt related compensating device is used. So for voltage and current harmonics, UPQC is used. This is a review of power quality improvement techniques which were existing in DG integration. This is a basic block diagram of DG. Here, all the sources will be incorporated to common DC link. Apart from the UPQC, it is integrated to grid. This is the basic configuration of UPQC, which is going to have both series compensator or shunt compensator, like series and shunt active compensator. It is shunt one is connected through the inductor, and this one is series one is connected through coupling transformer between source and load. Here, grid side, we are integrating along with the grid, we are using all the DGs. The simulation was done with MATLAB simile. Here, all the DG sources were incorporated along with the using to grid. Here, we concentrated only on current and voltage related problems. We assume or we construct the constant power source. Here, we can go behind grid. Block diagram. Here, DG, all the sources were incorporated to grid. Here it is considered under both linear and non-linear loads. So this is PV irradiance at constant irradiance. This work is done. It is examined under different irradiance condition also. So this is the PV power, which is almost constant. It is considered 6.5, which is going to have settled down at 2.5, 0.25 seconds. This is the power. Of PV at the same time fuel cell. This is a battery integrated with normal one unidirectional. Only battery is integrated with bidirectional converter. This is the comparison with the existing algorithms. Here, the algorithms results were considered based on the algorithm of like CATS form optimization. The comparison with the existing GSA graphical search algorithm and artificial backed form optimization and firmware optimization. So this is the DC link voltage, which is maintained constant. And at 700 volts, and this is under non-load.
The existing outside. No, and then we incorporate into the simulations that would have been.
Yes, the better one, sir. I will incorporate that. I will incorporate that one.
You have to just check
Yes, sir.
how close your
simulation tools, replicate the outside practical sources. That would give a reasonable answer to your application.
Application, yes, definitely.
Nevertheless, you have demonstrated
Only.
the improvement in quality of
Yes.
response. That's appreciable.
Okay, sir. Thank
Yeah.
you. Thank you. I will look into the conference. Thank you. On one more, sir, on behalf of Sri Lakshmi ma'am, and one of the other for this another paper, sir, I'm going to present the another review paper. Sir. For third one, sir. 473, sir. No, sir, just about that. This is a review paper, sir. Myself, Sri Lakshmi ma'am and Sri Shobha ma'am, we three are the authors of this paper. And the title is Emerging Technologies in Battery Management System for Next Generation Electric Vehicles. It is a basic review paper for getting the battery management system, the basic optimization algorithm. What are the algorithms available and what we can implement into this one. Coming to the battery management system, nowadays we are moving towards the EVs integration. So in this, to go with the implementation of EVs, what is the main motto or main thing we need to concentrate is battery management system. Here it is a crucial component which will observe, which will incorporate with the battery performance by monitoring the parameters like temperature, voltage, state of charge, current, and everything. So here we have to, while integrating the EVs, while designing the EVs, we have to face the problems of battery management system and what are the challenges and the demands here. Here the real-time implementation, real-time adoption is done for urban driving, highway usage, fast charging, and temperature variation. So this is the basic block diagram of battery management system which is available. Here, into consideration is voltage, temperature, current, and cell voltage. From this unit, the parameters will be given to algorithms, optimization algorithms, to have a proper management and to a proper communication between vehicles. So these are the key functioning, cell balancing, and protection mechanisms. These are the existing things. So we have to always time to time we have to track or we have to monitor the voltage, battery, voltage, current, and temperature. At the same time, real-time data adoption to improve the reliability and safety of EVs. So we have to balance the cell parameters like active balancing, passive balancing, and balancing of cells to ensure the charging and discharging of the battery. And the protection mechanisms were used for overcharging protection, over discharge, and short circuit protection. We need to concentrate on these three types of protections while incorporating the EVs. So these are the parameters which will describe the battery management system, which are to be considered while implementing the things. One is state of charge, state of health. State of charge means what is the availability of charge, which can be measured with a basic flow measurement, or which can be considered with open voltage. And state of health, which will describe about the current. And state of power. What is the power, maximum power under current condition? What is the available one, or to what extent we can use the battery without charging, or to what extent we can apply this one? So these are the parameters. So what are the basic types of BMS architectures for centralized, distributed, and modular? In centralized battery management system, only one main controller will be there, which will be controlling the entire system, which is designing easy, but communication problems we have to face. And distributed battery management systems, which will be distributed with multiple controllers, like for one object for one controller we can use. And modular. Modular one will be it is a combination of both. One main controller will be looking after the entire thing, and individual controllers we can implement for like the parts. So emerging technologies in battery management system. So we can implement the artificial intelligence or machine learning technologies for collecting the data for real-time data extraction at the same time for implementation to along with the existing methods to get the optimal control. One more thing is one more area we can look into this emerging technologies is thermal management innovations. So thermal management is also one of the key point we have to consider while integrating with the EVs. So here high energy density batteries face thermal challenges, especially during frequent charging and discharging of the cycle. So advanced cooling methods we can implement by using AI techniques and the cloud-based BMS system. IoT-based battery management system is another solution for existing EVs technologies. So cloud-based support for collecting the data aggregation, and for predicting or for forecasting the battery life or battery operation and everything. So these are future trends in battery management system. You can go with it's a review paper only, sir. Just to these are the methods what we can implement in the next generation. One is wireless battery management system and IoT based integration. The third one is vehicle to grid technologies. So coming to the conclusion, battery management system is a basic key basic key role in EV integration. So by using this new technologies or any optimization algorithms or IoT techniques, we can monitor the battery. So to avoid the problems which will be existing with existing batteries. Thank you, sir.
Nice presentation. What I would like to ask you, like, your overview them, all the others, but no way you mentioned from which literature you have brought the example, from where
That we mentioned in the papers. Okay, sir.
maybe it's a review
Yes,
presentation.
sir, review only, sir.
You should mention that
Okay.
because the credit has.
Okay, sir. Okay, sir.
And the next thing is what happens if the battery over voltage, that part also you might talk
Okay.
about it.
Okay, sir.
How many temperature sensors to be used for protecting the device?
Okay, sir.
That part maybe you can add it
Okay, sir.
because they are the preventive measures.
Yes, sir.
And you know that, madam, how many temperature sensors to be used?
No, sir, this is man's work on this. Just I'm co-author for this paper. Sir, actual work is by man.
To the knowledge, like each battery should have one temperature
Okay.
sensor, but that's the now, but the cost of the device increases with having one temperature
Yes.
sensor. So as the preventive measures, the transport department has decided to have four or more than that. Then only the vehicles will be allowed on the road.
Okay, sir. But I will look into it. Thank you, sir.
Next paper 488.
తీసుకొని ఎడిట్ అవ్వట్లేదు.
Good afternoon, all. I'm Divya, and I'm the faculty of Syria College of Engineering, Hyderabad. And today I'm here to present the paper, mathematical modeling of hybrid electric vehicle with PID music validated by directional backward standard. So basically, from 20th century onwards, there is a debate between renewable energy sources as well as the non-conventional sources. So basically, renewable energy sources are not meeting the requirement as of now. So, because the main issue is with the charging. The outline of this presentation is abstract system, proposed system components, and the basic converter and simulation results as well as model. So basically, there is a debate between the electric vehicle as well as the normal conventional vehicle, petrol vehicle, since 20th century. Because the battery electric vehicle could not give the enough energy for the future needs. So that is because of the charging. So if you compare 28 kg of battery electric vehicle as well as ICE engine, the battery electric vehicle is providing only 5 kilowatt hour of energy, whereas the required power is given by the ICE. So in this way, there is a competition between ICE as well as battery electric vehicle. But because after the next generation, we need to move on to the electric vehicle because the petrol or diesel is being vanished. So here we have improved the technology where we will be able to avoid the battery so that the vehicle can run for a long distance as well as we can save the amount cost incurred in the battery. So here we have focused on a solar electric vehicle which is inbuilt in the car roof as well as a fuel cell electric vehicle. So which will give extra energy to the solar electric vehicle. So this is the proposed system. So where we have used a PV system on the rooftop of an electric vehicle as well as a fuel cell, which will be able to compensate the needs when fuel cell when PV is not available. So in this, actually the reference feed is taken from the pedal and it's compared and it's given to the control system of EV where the comparison is done and the error is reduced and it's given to the voltage source converter. After voltage source converter, we have a quadratic bidirectional buck boost converter because it needs a maximum gain for the electric vehicle to move. So there is a block. These are the components which we have used: fuel cell, electrolyzer, and PV. In PV, we have used LPPT algorithm, the traditional LPPT algorithm. And this is a quadratic bidirectional boost converter, where we have categorized bidirectional boost as well as buck converter. So in bidirectional boost converter, there is a T2 switch which will be on off, and this will be giving the pulses to the respective elements or devices. Whereas in the next statement T2 is off, whatever energy is present stored in the inductor and capacitor will be delivered to the load. In buck converter, we have a T1 switch which is on and off. So during on stage as well as off stage, the pulses are generated and this is given to the quadratic bidirectional buck boost converter. So this is a proposed symbolic where we have a fuel cell as well as PV cell. These two will have a separate buck boost converters, and because the general DC-DC converters will not be able to compensate the load, we have used a quadratic bidirectional buck boost converter, which will improve the gain and the respective amount of energy is given to the motor, which is considered as an electric vehicle. So this is the proposed model, second model using PI and PID. So this is the rating of the induction motor, which we have considered as an electric vehicle. Basically, we have employed a vector control category technology for controlling the induction motor. So here we are giving the pulses of which are generated from the buck as well as boost converter at 1, 2, and 3 and 4 positions in the quadratic bidirectional buck boost converter. So this is the equations which we have derived and which we have implemented in the MATLAB simulate. So here we have considered 3 different cases, out of which the first case is when we have a constant irradiation and the speed. So in this, generally at PV, we need to generate about 480 volts. So even though the PV is giving 100 votes, it is able to, at DC link, it is able to upgrade it to 4. Very speed. Here also we can see that QVPC voltage, even though it has received 400 to 480 volts, you can see the increase up till 780 volts, which is needed by the induction motor. BCD. So this is a comparison we have made with between P and the conventional and PI controller, which is a proposed system. So the steady state ripples have been improved, uh, that is to 0.4%, whereas the trace time is also decreased to 1.6 seconds and stability time to 6 seconds. So DC voltage ripples have been reduced to 1.53% and stator current THT is improved to 1.05%. So overall, when we compare, we can see that the proposed system is giving a good output and it can be used in the requirements. So this is the conclusion. So basically, we have applied in the MATLAB. So in addition to the MATLAB, we can also use some AI techniques like artificial neural intelligence or MPC, so that we can improve the output further.
Okay, nicely presented. From your results, like case one, case two, case three, you could see that initial inputs are high.
Yes.
And in the case three, even in the constant flow also there are ripples. So you may use some technique, maybe a suggestion, maybe a fuzzy technique, fuzzy PIO, PID techniques are there. So they are mainly for reducing the initial ripples. So
Yeah,
then we can concentrate.
yes, sir. I have tried it with the MPC also. So it is showing the better result. So I want to present it this paper, so I did not put it this paper.
But for this, maybe the ripples are very high.
Yes. But compared to the conventional method, it is reducing the reports to maximum.
Good.
Thank you.
From audience side. Okay.
Thank you.
Division. Mother, 488. 285. Yeah, we'll end up this section now and we'll join for the lunch. Then after that, we will again relate about 2 o'clock for the section 2. The lunch is at rented in the lobby. You can join there.
You all. Reduce to. You are, please stop it. Yes. Yes, yeah.
Second year, but lunch is been arrange in the ready on the good things in the
Very good.
Would you want to plan for you? Because you are thinking.
Nearly 12% of students. Reduce to safety companies. You have done 3 activities at student places. You at Kochi and on a caricature also. Having some meetings also have. Regular work subsection. Optional meter. And the information. To be surveyed. You would be on it. The section audit on it, the me that. It's the nature of. Yeah. There's another leaders we waited at